In this video, we are going to do a reverse engineering product comparison. We're going to take three reverse engineering software products and basically show how they work, basically show a workflow. So what we're going to do is we're going to show the VX model product from Creaform. We're going to then show the Geomagic for SolidWorks from 3D Systems. And then finally, Geomagic Design X also from 3D Systems. Now, the point of this demo is to really show just how they compare in a basic workflow. This is not going to be an in-depth demo of each product. We have plenty of other videos we've created that go into more detail, and some are very application specific. This is just going to show taking the part you see here that was already 3D scanned and showing what the workflow would look like. So this part has a little bit of everything. It's got some surfaces, it's got some primitives, and it's got some other geometry. And we're just going to show what the workflow looks like to be able to take this scan data and then build a 3D CAD model in each one of those products, just to give you a general idea of how they work. And we'll talk about the benefits of each one of these products. And finally, we'll just kind of show a summary of the three different products and kind of how they compare to each other. All right, so we are going to get started in VX Model. Now, what is VX Model? VX Model is sold by Creaform, so if you're using a Creaform 3D scanner, this could be a nice add-on because it allows you to kind of stay in the Creaform world, so to speak, for the most part. You're gonna see the workflow here in a minute. But basically, if you have a Creaform 3D scanner, you basically do all your scanning, and then you open up the VX model, or you just say import into VX model, and it brings that scan data straight in. It is an add-on product. So the basic product from Creaform is called VX Elements, and that's your basic capture software. That's included when you buy a scanner. VX model would be an add-on. So basically, when you're done scanning, you tell it you want to start modeling. So you'll see our model here. It was just a small plastic part. We scanned the top of it, didn't bother with the bottom because it's flat. And you can see that scan data. So what we're going to do now is kind of show you what the workflow might look like. Now, just real quick, the interface, pretty typical. You've got kind of a ribbon interface across the top. We've got some different selection tools you see here. You've got your modeling tree over here, and just some other details. So the first thing we need to do is extract information, because the way this product works is we extract information from the scan data, and then we take it into the CAD system of choice, and we do the actual modeling. So we'll do a few things, and it'll hopefully make sense. So first thing is always determining how you're going to model, right? Looking at this, what makes the most sense. We don't have a bottom on it, so probably the best place to start is this nice flat feature here. Being a plastic part, all the walls have draft, so we're going to want to start here. So what I want to do is basically create a plane. And one of the selection tools in here is called similar curvature. And if I click on the part, it's going to look at the curvature of everything and just select, in this case, what's mostly flat. And I'm going to go in here and I'm going to say create a plane and hit. And you'll see it gives us within a tolerance, what's everything in green is flat. And we can see some blue and red. That's just telling us, it's fit a plane through here, but it deviates a little because probably the part has a little bit of warp to it, but we're good with that. So we've built our first plane. You can see it's right on there. So now I really don't have anything to set up that bottom plane. So now I'm going to create a plane by doing a plane offset, and we're going to select our first plane, and let's get this in a kind of a side view so we can see it. And based on the vector direction, I want to go down, and I'm just going to manually click this. So let's try maybe 12.5 and see how that looks. I'd say, yeah, that looks pretty good. And we'll create a plane, because it would be very difficult to try to pick the edge down here. Edges of scan data are never, really reliable. So that's given me two planes. So I've identified this top plane and the bottom plane. Now, this out here is very curved. So you know, we're going to have to do something different for that. But let's start with this. So now I want to start extracting some basic profiles. Okay, so I've got my two major planes here, and now I'm gonna get some profiles, and then we're gonna take all of this into, in this case, SolidWorks. We'll talk more about that in a minute. Okay, so first thing I'm gonna do then is I'm gonna say I want to create a cross section, and I'm gonna pick an existing plane. Let's start at the bottom, so that would be plane 2. And we don't want to cut it right at the bottom edge here because that data can be unreliable, and you can see the part's not perfectly flat on the bottom. So maybe we come up, let's try 0.1 and see what that looks like. Maybe a little bit more. We want to try to get it to a point where we've got that line all the way around, which looks like we do. We don't want to go up too far because we have draft on this part. And I'll say, yep, that looks good. And it's going to create that first cross section. And then we're going to want to take one here because this is another, again, prominent feature. So that was, I believe, plane 1. And this one we're probably going to want to go up a little bit more because we want to get away from the radius here. Maybe 1.25. Let's see how that looks. Right? So we want to get off that radius, okay, because the radiuses we're going to put in later. And we'll go ahead and say create, okay? So we've basically created the main bottom profile and then this cutaway profile. And we will repeat that process for the rest of these features, but we'll come back to those because we can do this in steps. Now, the other thing, it's obvious right away that this has a lot of curvature to it. So we're not going to be able to just do a kind of a blind extrude. We're going to need to cut it off with this. So we're going to use over here, we've got some surfacing tools. There's auto surface, and that'll just build a whole patch of surfaces on the part, but it's not very intelligent. That's great for a very organic part. It's not good for a part like this. And again, we're going to try that similar curvature feature because basically we're going to want the surface to fit to that. And let's see what a preview would look like. And we can adjust the amount of control points, how tight deviation-wise we want it to touch. You know, if we really want to crank this down, let's try 0.1 and do another preview. That'll pull it down even tighter. So you have a lot of control over how well that surface fits. You can see we're extending out, which is fine because we're going to actually use it to cut later. So let's go ahead and hit create. Okay, so let's close out of here. And if we look at our entities in our tree, we've got a couple of planes, a surface, and a couple of cross sections. So that's enough to get started. So the next step is to transfer this. Now we have two choices here. We can go to SolidWorks, Inventor, and Solid Edge right from here, or we could basically export out the geometry into like an I-just-step parasolid, okay? So we'll have different options. But since we're using SolidWorks in this demo, I select all the geometry, and then I hit Transfer to SolidWorks. Okay, so here we are in SolidWorks. So the data is automatically transferred over. And if you look at what we have, excuse me, the top surface, and then the two cross sections, and then the two planes that we created. So I like to kind of hide the things I'm not working on. It just makes things easier to work with. So I'm going to hide plane 1, and I'm going to hide cross section 2. And so now we just have plane 2 in that cross section. Now, why did we bring in the plane and the cross section? Because if you remember, they're not at the same level or the same height. The plane is right at the bottom of the part, and the cross section is up just a little bit so we can get that nice cut. And also, what is this cross section? Well, it's a polyline. It's just a bunch of points on a line. It's not a line like 2-point line. And if you had fillets or radiuses, they wouldn't be. It would just be points. So it's not the best geometry to be solid modeling from. Also, you can see it's incomplete. If the scan data isn't complete right there, you're going to have holes in it. So what we're going to do is just use it as reference geometry and build new sketches. So what we're going to do is we're going to go to the sketch command and pick this plane because we know it's right at the bottom. And let's go ahead and get into a top view. And we're going to basically kind of trace around this geometry, but we're going to do it with the real sketching tools over here in SolidWorks. So I'm just going to line up the corner, and then I'm going to come down here and I'm going to line up and just try to get right over the top and build that first rectangle. Now, the rectangle, of course, things will be parallel and perpendicular. Now, you can add other things. If you want to dimensionally drive this and add all that, you can do it. We're not going to, for time in this demo, not going to show all that. But you have all your normal sketching tools. Because normally when you scan something, you're scanning the manufactured part, which is not going to be perfect. It's going to be slightly bigger or slightly smaller because of just shrink and different manufacturing processes. So you can override all that just like you would on a normal sketch. Okay. So there's our first sketch. We can now exit out. And now we want to turn back on our surface, and we are going to go to Features. And again, we're using all SolidWorks commands, and we are going to want to extrude, and it's going to be that new sketch we created. Now, we don't want to go blind. We could, but we know the top of the part has some real shape to it. That's why we extracted that surface, and now we can use that to automatically fit right to it. The only other thing we want to do is add draft. Usually 1 or 2 degrees for an injection mold in this case, and then hit OK. So let's go ahead now and hide that surface, and you can see very quickly what we have. We have a nice, the kind of the major shape of the part with that, that very, complex, very organic top that it has, very quickly. So next, let's go ahead and show the other cross section and turn on the other plane. Let's hide this one and hide this one. Again, for me, it just makes life easier. Okay, so we pretty much want to do the same thing. We want to now make this, in this case, it's going to be a cutout. So same process. We come in here, we hit Sketch, we pick our plane. Let's go to a top view. And then however, you would trace over this. So I'm going to start with a line here and just run it out. Doesn't matter where it goes. And let's go here and same thing. And then we'll just kind of close it off out here somewhere. And then last thing we're going to do is create our fillet, and that'll be here and here. Try that again. Let's try this. We want our fillet here and there, and let's type in our amount. Let's try 1.5. Let's try 1.75 and say, hey, that looks pretty good, and go ahead and take it. And then now we'll go ahead and exit this sketch. Okay, so there's our second sketch. And now we are going to want to do an extrude cut. And in this case, sketch 4. We're going to go up. And then for this one, we're going to want to also add draft, but we're going to want to draft outwards, right? Because we're going to cut it away. So let's go ahead and hit OK. So that's going to give us our draft. So again, very quickly, we have created this, a good majority of the shape. So that's bringing in a couple of sketches and doing some extrudes and cuts. Next, let's show what you might do with some primitive objects, some primitive surface or solid objects. Okay, so we're back now in VX Model, and we want to continue on. So let's go ahead and hide the surface and those two planes for right now. And let's take a look at this geometry here. So we're going to do this geometry a little bit different because these are more prismatic shapes, cones, cylinders, spheres, things like that. So what we're going to do is extract that information as primitive geometry and then take that into SolidWorks. So let's start with the spheres. And again, we're going to use that curvature-based selection tool and then go ahead and hit Create there. Create there, and create there. So what this has done is it's actually built solid model geometry by fitting through that scan data. Okay. Now you could also set up a center axis and then cut a section and then do revolves. That's certainly a way to do it, but I thought we would show some of the other commands. Now, let's go ahead and do these. And theoretically, this is certainly a cone, but actually these two are cones too, in the sense that we've got draft on these walls. So we could do it either way. We could do it as cylinders and then change it in SolidWorks. Let's just go ahead and try to do it all as cones. So now what we're going to do here, because the way that curvature-based works is it's going to stay away from the corners because of the radii there, right? And so you can see our geometry then only fits to where our selection was. Now, we do have some things we can change over here, like the height or the distance from the apex. So, for example, if I change the height, let's spin this around so you can maybe see it from underneath. You can see, and I'm purposely, what I want to do for this is just get the bottom to go down a little bit farther. This will make sense here when we go into SolidWorks. The top I'm not so worried about, but the bottom I want to carry that curvature down into the part a little bit, and then I'll hit create. Okay, so we'll do the same thing here with that. Let's flip that over, and let's increase that one a little bit as well, and hit create. And then finally this one here, and change that height. Okay, and that's good, and then we'll hit create. Okay, so once we have those, now I'm going to need a couple of planes. If we look at the, let's call it the shoulder or the top flat area here, there's a couple ways we could do this. We could certainly offset this big plane and move it up. That would probably be the right way to do it to make sure it's parallel. If I'm not real worried about it, I'll just do it this way, and I'll sample data from both of those. The only danger here is it's not guaranteed it's perpendicular from this, but just to kind of show you a couple different ways of doing things, we'll just go ahead and do it. And then same over here. And the reason I need this one is because it's at a different height. Okay, so let's close that. Back to our tree. So we're going to want this plane, all three spheres, and then all three cones. Okay, and just like before, we hit the transfer to SolidWorks button. Okay, so now we're back in SolidWorks, and what's nice about this is you can go back and forth, and it automatically just keeps bringing in and updating your current model. So you can see we've got our geometry in here, and first thing we're going to do is take and edit some of these features. So we'll grab this one here, and we're going to change it from a blind extrude to up to surface. And we're going to pick that plane that we created that we know is, at the correct height. And then we'll do the same thing here. Change that up to surface and pick that plane and hit OK. And then finally this one here. Up to surface, and then that's plane 4 in this case. Okay. So there we've automatically adjusted the height to be at the proper height on those just by, again, extracting that plane. Now, the bottoms, like I said, we just ran down into the part, and all we got to do now is go to Insert Features and hit Combine, and just combine all this geometry together to make it one solid body. So then it will get all the proper trims on those. So that's how you would do more prismatic stuff. So just to kind of recap a little, we extracted planes and then cross sections. We brought those in. We built SolidWorks actual sketch entities, and then we did some extrusions, one with a cut for the surface where we extracted. Let's go back into VX Elements and look here. So all we really have left is a few more cutouts and holes. And we'll just use cross sections for those, but you get the idea. It's really just the same process over and over. So let's Let's take a look at what the final model looks like in SolidWorks. Okay, so here is our final model, and really what we did is we just brought in those sections or contours and did some extrudes and cuts like we did before, and then we added all of the fillets to our part. So we have a fully modeled part now with a full history tree that we could roll back through and make changes as need be. But that's basically the workflow. So again, in VX Elements, you create some geometry, and then you either extract it straight into SolidWorks, Inventor, Solid Edge, or you export it into, iJustStep, Parasolid if you're using a different CAD system, and do it that way. It's just an extra step of exporting and then going into your whatever CAD system and then importing it. So, but that's the basic workflow using VX Model. All right, so just a summary of VX Model. Starting with the benefits. One of the main benefits is it works directly with Creaform 3D scanners. So if you're already in that world, you could go right into the VX Model module just with a click of a button. And it's not to say that this won't work with other scanners. Theoretically, anybody could buy a VX Model and import scan data, but the typical customer is going to be a Creaform customer. The product is very easy to use. Creaform has some great e-learning tools and help guides and tutorials and very, very good stuff. It's fairly easy to learn on your own. It has the direct links to SolidWorks Inventor and Solid Edge, but you can work with any CAD system by outputting those neutral file formats. And finally, it's the lowest price of the three products we're going to show here. Now, we're not going to get into pricing because pricing can change and it's different in different parts of the world. But of the three products, this is the lowest priced of them. And then finally, things to just consider with VX Model. And it's not a standalone CAD system. You can't do all those CAD features, sketching, extruding, and making drawings, assemblies. You're really just using it as a tool to extract information and take it into a CAD system. So you really have to have a CAD system. And it does have limited features. It's great on kind of sketch-driven parts and some basic surfacing. There is also some auto surfacing. So you've got some decent all-around tools. Not as many as some of the other products, but those will come at a higher price. But if you want a basic a system to be able to scan and extract information very quickly in an integrated system, it's a great product to consider. All right, so next up is GeoMagic for SolidWorks. Now, the way this works, let's go ahead and start a new session here in SolidWorks, or a new part. This runs truly integrated inside of SolidWorks. So you'll notice feature sketch, all your normal SolidWorks stuff is here. And then down on the end here, we have GeoMagic for SolidWorks, and it's got some tabs, or more of the ribbon style. So the first thing we're going to do is import scan data. And let's go ahead and import our scan data we created. So we would have exported that, in this case, from VX Elements, but this will work with any scanner. You can even do live scanning right inside the software. I normally don't do that, but some people want to be able to scan right in here. I like to just save it and then import it in. So here's our scan data. You can see we've clicked the import button. Now, you've got some nice editing tools. You have some point cloud tools here, and then you have some nice mesh editing tools. And again, we're not going to go into these. We have other videos that show these in great detail. But if you need to do some mesh editing, you can do it here. And then really the rest of this stuff is what we're going to be primarily using. So we're going to start with the region group command, and we select that. And we've got some adjustments here for sensitivity and connecting regions. The defaults usually work pretty good. We'll start with that. If we don't like it, we can redo it. But what it's going to do is very similar to the VX model command where we had it select by similar curvature. It's essentially kind of done the same thing, but it's taken the scan data and color-coded the mesh. So you see planes, cones, spheres, even this freeform surface up here. All it's did is color-coded that mesh kind of by groups And it just makes selecting and working with them a little bit easier. So we don't always do this, but for parts like this, it makes total sense, and you'll see here in a minute. So the first thing I want to do, like we did before, is create a plane, and I'm going to come to this extract reference plane, and I'm going to use select regions, but you can use other SOLIDWORKS selection tools like lasso. But what's nice about the regions is I just click on it, and it's going to automatically fit a plane right through that region for me. So if we now go to a side view, we'll use the SOLIDWORKS copy plane command, and we'll just drag this down. And again, we can key in a key amount here because, again, trying to create a plane right off the bottom edge of scan data can be difficult. So that gives us 2 planes to start with, like before. Let's hide the top plane. And now I want to create a cross section, and I'm going to pick this bottom plane, and we're going to want to move it up some amount like we did before. We don't want to cut right at the bottom. I'll go ahead and take that amount. That's fine. And then that's going to build a cross section through there. So if you turn off the scan data for a minute, let's take a look. So what it does is it cuts this through the scan data and basically builds it as construction geometry in SOLIDWORKS. So it's kind of like reference geometry. Theoretically, you could turn that setting off and it would be real geometry, so to speak. But like before, it's not perfect lines and tangent arcs and parallel and perpendicular. It's just reference. So we're just going to use it as reference like we did before. So we will go over now to the SOLIDWORKS sketch command. We're going to sketch. We're going to pick the bottom plane because we know that's right on the bottom. And then we're using SOLIDWORKS, sketching tools. So let's do the rectangle again. And again, we'll just kind of get it close. And you can add dimensions and all the constraints you want to add. But that gives us our first feature right on the bottom, or our first sketch right on the bottom of the part. So let's go back, turn on our scan data. And we're going to extrude up to that, very organic shape at the top. So we've got a tool here called Extract Freeform. And same type of thing. We're going to pick the region group. And it's going to fit a surface. It's automatically going to extend it. And we can control how accurate it is, how far out we want to go, and basically build a surface skin. And you can see that there. Now, one of the neat things in Geomagic for SOLIDWORKS is I can do a deviation analysis on that. So if I pick this skin and I hit this here, it's going to show me how close it is to the scan data. So you can see over here in green, and I can set what this tolerance range is. So we can see for the most part it's pretty good, but right here and here, it's actually cutting under a little bit. So we could go back and crank up the accuracy and do some different things to get it to fit even better. Now, I'm not going to worry about it. It's not that critical for this in this case, so we're just going to leave it. So let's turn off the scan data again. And now we are going to do a extrude. We are going to pick, let's get our tree out here. We want to select sketch 4 in this case. And again, we don't want to go blind. We want to go up to a surface. And we're going to pick that top, and we're going to create that. So let's hide that surface. And you can see what we have. So we have that basic shape starting at the bottom and then going up to that very organic shape of this part. So next, let's go ahead and bring our mesh data back on for a minute. Let's go ahead and hide our main solid body there. And let's look at doing our next sketch. So we'll want plane 4 back on. I'll turn plane 5 off. And let's turn this some of this stuff off too. There we go. So that's the plane that sits up here. And we'll go back in here, and we're going to say cross section. We're going to pick this plane. And once again, we want it to be up above, in this case, that little radii. And I'd say that value also looks pretty good. So let's go ahead and take that. And let's hide our mesh. And again, we have that nice cross section there. So let's go to Sketch. Let's look at this straight on. And we will use a line and just kind of draw that out here. And another line here. And then just connect really the two anywhere out in space. It doesn't really matter. And we're going to use the fillet tool here. Let's try that again. There we go. And I believe this was 1.75. And we'll hit OK. So again, we've got a nice closed sketch. We can exit out. Let's bring our solid body back up. And back to features, extruded cut. I'm going to pick this. And we're going to go the other direction. And we don't really care how far we go. And now we've made that cutout. So let's start working on those primitives. So we're going to bring our scan data back so we can take a look at it here. And we have some similar tools. Again, we'll use the cone command. And we'll just pick the region group. We're going to make this a new entity. And you can see the enlargements will allow us to make it go beyond the top and the bottom, especially the bottom. So we'll go ahead and take that. And then we'll do the same thing here. Take that. And again, you can see how easy it is by just picking those region groups, which are all already defined. And we're going to go ahead and do the same thing for the spheres. And you can see, if you look, you can see what it does. It's actually building sketches. So just like you would sketch and revolve. So if you ever wanted to go back and edit this, you can actually go and edit the sketch and it'll update the solids. So, so now we have those. Let's go ahead and hide our scan data. And now we're going to want to trim this up. Actually, let's bring our scan data back on for a minute because I do need those cutting planes. So I'm going to extract, and we'll do it the same way as we did last time. I'm going to pick those two areas here and fit a plane. And then we'll do the same thing over here and pick a plane. All right, so we have that. Let's go ahead now and hide the scan data. So what we're going to want to do is come under here and say Insert Cut with Surface. We're going to pick the surface here. And we're going to select this body and flip the normal. And that's going to cut it off at that plane. We're going to do the same thing over here with surface. Pick this body here. And go ahead and cut that off. So that'll cut that the tops at the right height there for us. And now we can go in and just join them all together. All right, so if you look here, let's hide these planes. And you can see where we are. So let's bring back our scan data. And again, that accuracy analyzer tool, I can use at any time. So if I go here, deviation analysis, I select this body and say, show me the results. You can see what that looks like. So it's a nice tool. Again, we haven't done these cutouts yet. We'll do those next. But I can look at this and say, hey, that looks pretty good. Looks like we've got, a little bit of bending here. We don't have our radiuses on here yet. But it's a nice tool just to kind of see, how we did. I think we forgot to extrude with draft, and that's certainly showing here. So we could roll back to the tree and do that. And that's the beauty of this is it's a SolidWorks model. You're working in SolidWorks. So let's go ahead and do that. Let's go back to this feature here and edit it. And let's add that 2 degrees of draft. So we'll fix that there. And then we also need to do it on the other feature, the other extrusion. And that one needs to go outward because that's a cut, and add it. So now let's take a look at our deviation analysis and see how that looks. So you can see now this looks much better because we've added the proper draft. So in this aspect, it's just like a SolidWorks model. All the features in the tree and everything acts the same way. So you can go back and make changes, and you always have that tree, and you can go back and update. So we'll go ahead and add the final features here and just show you the end result. Okay, so here's our final part. We added in those additional features, and then we added the radii to everything. Even went ahead and ran the shell command to make it like a plastic molded part. And let's go ahead now. The last thing we'll do is turn back on the scan data. And let's go ahead and run that deviation analysis one last time. Pick our part and see how that looks. So as you can see here, it looks pretty good. We've got a little bit on these contoured surfaces that we talked about, and that's just how tight you want to pull that down to. But if it's just aesthetics and you just want it nice and smooth, you can see. But overall, the part looks pretty good. We can see some yellow here. That's probably because the part itself we scanned was a little bit warped in that area. And, we want to design it back to the as designed, not the as manufactured. But other than that, everything else looks pretty good on this part. All right, taking a look at the benefits of the Geomagic for SolidWorks. Well, the biggest advantage is it works right inside SolidWorks. So if you're already a SolidWorks user and want to start doing 3D scanning, or even if someone did the scanning for you and sent you the scan data, you already know SolidWorks. So you've just got to learn some additional commands. So that makes it easy to use, again, assuming you know SolidWorks. If you don't know SolidWorks, then you're going to have to learn SolidWorks as well as learn the Geomagic for SolidWorks. But you have access to all the tools in SolidWorks. We extract the data from the scan data, and then after that, we are using SolidWorks sketching and features and everything of SolidWorks. Now, some things to consider is it only works in SolidWorks. So if you don't use SolidWorks, you use a different CAD system, this probably isn't the right tool unless you want to go out and buy SolidWorks, because you have to own SolidWorks for this to work because it plugs into it. It doesn't have all the features of Design X, which we're going to get to next. And it will struggle with large data sets. One of the challenges of trying to build this into SolidWorks is SolidWorks is not built for huge 3D scan data sets. That's not what it was intended for. So when we start to get into larger ones, it will really slow it down. And there are some tricks to working with it, but it could be a challenge. And its price point is going to be higher than the VX model. It'll be lower than Design X. So it's kind of in the middle. So those are some of the things to consider with Geomagic for SolidWorks. All right, so next up is Design X. And what's different about Design X than VX Model and the Geomagic for SolidWorks is it's a standalone product, meaning it has a full CAD system in it, as well as all of the mesh editing and surfacing tools. And it uses the same Parasolid modeling kernel as SolidWorks, Inventor, and Solid Edge, and the same sketching tools. So one advantage of Design X is you don't need another CAD system at all. Now, it doesn't do drawings, it doesn't do assemblies, and it doesn't do a lot of other things that SolidWorks and other CAD systems do. But if you wanted or needed a standalone modeler, this would be the choice. Now, again, we have very detailed demos on DesignX, and we're not going to go into all that today. We're going to, again, try to just create the same workflow just so you see how it works. So, again, similar ribbon style interface. You've got menus along the top, for example, for here's all your solid modeling, surface modeling. It's got all kinds of mesh editing tools. It's got tools for working with point cloud data, which we're not going to get into today, but certain types of scanners work in point clouds. So it's got all kinds of tools for that. I mentioned the mesh editing, and just, again, 3D sketches, all kinds of very deep product, very robust. But today we're just going to focus on this workflow. So first thing I'm going to do is I've already imported the data. And again, that's just would be saving an STL file from whatever scanner you're working with and bringing it in to DesignX. And we're going to run a region group just like we did with Geomagic for SolidWorks using the auto segment command. The defaults usually work pretty good. So this is going to be very similar to what we did with Geomagic for SolidWorks. We're going to create this region group, and you can see it's color-coded that for us. And you'll see when you highlight over, it'll tell me what kind of entity it's identified it as. So cone, sphere, plane, revolution, or freeform shape, plane, etc. So that's kind of nice. Okay, so like we did before, we're going to create some planes to start out with. So I go to my plane command, and if you look over here, you can see all the different ways I have to create a plane. And that's one of the advantages of DesignX, is it's a very deep product. There are so many ways to do things in this product. So I'm just going to use the extract and pick the plane on there. And if I do a little preview, it kind of shows me the data it's going to use, and I get my first plane. Okay, so let's now jump into a side view here, and we'll turn off the mesh just for a second, and we'll just drag a plane down and then turn it back on. Again, there's so many ways to do this. If I double click the plane and go to offset, and I'm working in mils here. You've seen me going back and forth from mils to inches. I work in both, but you can set ahead of time, like if you want to work only in mils or only in inches. All of these products are capable of doing that. Okay, so we've got our bottom plane, and like before, we're going to want to create a reference sketch, or mesh sketch as it's called here in DesignX. So we've got a sketching tool, and that allows us to do mesh sketches or just 2D sketches. And again, because it's a full CAD system, I can just create geometry even without scan data, and that would be more of 2D sketches. But we're going to do a mesh sketch on this bottom plane. And same thing, we're going to want to sample it up, and you can see this is interactive. So I'll move it up. I can either type in a value or just use the slider there, and then hit OK. Now, one of the differences is this mesh sketch will be right on the bottom surface. So let me hide the mesh. If you look, so instead of being offset like the other products, even though I moved up the plane to sample it, it's actually going to put it right down on that bottom plane, which would have been plane 2. So I don't have to worry about it. It's a little different in here. Okay, so let's go to the top view, turn that plane back off, and then I have all the sketching tools. Again, same sketcher as SolidWorks, so it should look pretty similar. And one nice thing is I can just window in on the area I want, okay? I could do the rectangle. I'm just going to do it this way here just to kind of show doing it like this, okay? But again, I could do the rectangle and window it in. And then you can do all your things like make it horizontal, perpendicular, basically add all your constraints. You can add dimensions and so forth. So, but let's go ahead to do it. I just wanted to show that, but let's to keep things consistent. Let's do the rectangle. And again, I'll just kind of eyeball it, and it kind of snaps right to the geometry, which is kind of nice. But again, I can always just move things around. Now, one of the things we can do in here is we've shown the 3D deviation in the Geomagic for SolidWorks, but here we can actually do it in 2D. And what I'm going to do is I'm going to amplify this little slider here. I'm going to amplify it so I can see it better. And let me zoom in and I'll explain what we're doing. So the pink line is the scan data, and then the blue line, of course, is our new CAD data. Well, you can see, and if I hold my cursor over one of these little whiskers, you can see, and green over here up to zero point 0.1 millimeters or 100 microns, we're saying is good. So if I highlight over these are all good, and then you see it turns yellow. So now we're approaching, out of at least whatever we've set at tolerances, all the way up to here. So what's really neat, so what does this tell me? This line, down here, we're pretty good, right? You can see we're right on. But as we go over here, we can see this part is not straight. It's got a little bit of angle to it. And again, we're scanning an as-manufactured part. That's very typical. But one thing I can do is I can move, I could sit here and move this line and try to, so here you can see I've kind of averaged out that deviation, okay? So I could go around and do that. That's a really cool tool. So you're basically doing a kind of a 2D accuracy analyzer right here, right on our sketch. We don't have to wait till we've turned it into a solid body. So that's something really nice. And again, you can add all your dimensions, all your constraints. We're not going to do that here just for time purposes, but you see that. So there's our first sketch. So bring our mesh back on, and you can see we've got our bottom sketch there, okay? So let's go ahead now and create that mesh fit surface. So we're going to go back to our modeling tool. We're going to hit mesh fit, and we are going to just pick this region. And again, we have a lot of tools in here to do this. We can go by control points, by deviation. We can adjust the smoothness. I'll show you this manipulate UV axis. There's some really neat tools. So for example, let's go to step 2. You can actually come in here and pull these little UV nodes around. Maybe you've got a certain area you want to kind of adjust this. This starts to get really technical, and that's the thing with Design X is there's a lot of depth, like I said, to this product. So you can tug these around. That can influence the surface. And the other neat thing you can do is I told it 20 by 20 control points, but I could come out here and move things around or copy them or delete them. So, let's say I didn't want that one and then actually pull one off here and move it. When you get into some really heavy surfacing, some of this can make a difference on how it controls it. Let's just kind of take it, and you can see what we've got. Now, again, we can do that deviation map like we did. Let's crank the resolution up here and redo that. So again, ignore all this because that's down below, but we're really looking at this. So you can see I've pulled that nice and tight. And another neat thing, let me turn off that sketch. Another neat thing is I hold my cursor over, you get this little readout, and that's the distance between that surface and the scan data, okay? So that's, again, a really nice feature. And again, we're building a history tree over here just like you would in SolidWorks or anything else. So there's that surface we need. Let's bring our sketch back on, and we are going to do an extrude. We're going to pick that base sketch. And then we have all kinds of options. One of them is, so we're doing a blind as the default. We can go through all to a vertex, to a region, to a surface, etc. Now, what's neat is a lot of times I don't even need to build this surface. If the region fully encased where this would extrude up to, I could just pick region. Because it's only this area here, it won't work. That's why I needed the surface. So we're going to go up to the surface. Okay. And then hit OK. And if we hide the surface, so you can see what we have here. So we've got that. Now, we also can always go back. Let's go back to that extrude because, again, I forgot to add draft. So let's click draft. And again, that's always the beauty of history tree modeling is you can roll back. Okay. Now, again, we can do that deviation analysis, and this time we're doing it on the whole body. So you can see what we have here on the body, and again, I can highlight over, but let's look at our sides, and we can see what we have here. So you can adjust this accuracy to whatever you want, but that'll show you what that looks like. So let's go ahead and work on some of these primitives like we did on the other one. I'll hide the solid body for a minute. So similar, we have this primitive tool, and we can automatically extract shapes. So again, just a lot of depth of the product, or we can extract a specific shape. Let's start with the spheres. And one nice thing is I can lock this tool so that it stays open, so I can just keep picking things and working. So I use that quite a bit. Now we want to do the cones, and we're going to want to extend them out like we did before. So I don't know, let's go 5%. And we can also do a preview to see what that looks like. So we don't commit to it, and we can go back. And what's nice about that, when you're doing some of these commands, we get into really big data sets. It can take a while, and the actual preview actually works a little faster. I'm not sure how, but I've been told that it will do it faster, maybe because it doesn't write it out to disk or something. But for this, it really wouldn't matter. But if I was working with a really large data set and wanted to execute a command quicker, I can do that preview. And then once I like it, I go ahead and hit OK. So let's do this one. And again, I could preview it if I want, but I believe that should be fine. And then pick this one here and hit OK. All right, so let's go ahead and we can unlock that and turn it off. So now we should have similar geometry as we had before. And we're going to need a plane. Let's hide this. So we will go to plane. We will go to extract. And again, we'll pick this region group and this region group, just trying to do things the same way. Okay, and then repeat the command on this region group there. Okay, so display those planes. And then bring back the solid bodies, hide the mesh. And it's going to be the cut command. The tool will be the plane. Target bodies will be this one and this one. And then it's going to ask us what side to keep. And then we'll do the same thing over here. Target body. Next step, what side to keep. It's kind of hard to see because it's so thin, but I'm picking. You can kind of see the bottom piece there. Okay, so we have those. And then for the rest of it, we can just do a Boolean. We're going to do a merge, which is like a combine. Select all and hit OK. So we've got those. Let's hide our planes. So you can see what we have. Now, I'm going to show one more command. I didn't show it in the others because it was just, which is the fillet command, because you just say fillet and then you pick an amount. What's really neat about this product is I can pick this fillet, and it's coming up with 2.54, but that's just whatever was in there. If I click this little button here, it's actually going to go look at the scan data underneath, and it's going to average or evaluate it all the way along that curve and then come back and tell me what it should be. So that can be very powerful, right? And you can get into, variable fillets, face fillets, full fillets, etc. And this can be a very handy tool. So now it's come back with 1.2052. I can say, well, I would guess the designer made that 1.25. So I can override it, but what's really neat is I can sample that data underneath to get that. So then we just go around, we would add all the other fillets, and then do the other cutouts, like we did on the in the other two products. So let me show a couple extra things in here with some of this geometry. So as I mentioned, if I go to sketch and I say mesh sketch, I don't even have to build a plane ahead of time. I can just pick that region group, and then I'll slide it up a little bit and then hit OK. But that mesh sketch, as I mentioned, is right on that region group. And then I can use this auto sketch command and window in, and it'll automatically build the sketch for me. Now, this works great on basic geometry. When you have really rough scan data, it's full of holes, or it's really complicated, it doesn't work as well. But it's a nice productivity tool. You can see it just quickly was able to do that. I've got my sketch. I go back to my solid, And in this case, I'm going to extrude up with a cut. And you can see, so it's very quick. Let's do the bottom one as well. So same type of thing. So I'll come in here, sketch, mesh sketch, pick the region. This time we're going to sample down a little bit, hit OK. Come over here, hide the mesh, come in and do auto sketch, window that in, hit OK, and you can see just how fast I have that. Bring my solid body back, and we are going to extrude this time the other way with a cut, and you can see. So that just kind of shows you how quick, I already cut this one in over here, but how quick you can get those reference sketches and then use auto sketch or the other sketching tools. Okay, so we've added all of the fillets and finished up this model here. Let's do one final deviation analysis just to see how everything looks. And overall, it looks pretty good. We can highlight over as we've shown before and looked at the deviation. We know we've got issues here, but that's on the part, and we always want to design back to the as designed. So for example, this should be a plane. We don't really want to follow those imperfections in the part. So overall, everything looks good. Now we're done. Now let's say we want to go to downstream applications like CNC machining or something else. We can come in here and we can click export. We can pick our solid body, and then we can output neutral CAD formats: IJustStep, Parasolid, even CATIA in a native CATIA format. So we can do that. The only issue with that is it's a neutral file, so it's what people refer to as a dumb model or a dumb solid, because there would be no history tree. And for a lot of things, that's fine. But if we're going to go into a CAD system and do assembly modeling or dimensioning, making drawings or something else, or we think we want to make changes to it later, it would be nice to have that history tree. So what we're going to do here is I'm going to slide this over a little bit. And what I've got up over here is SolidWorks. And we're going to do what's called a live transfer. So I'm going to go File. Let me get this started. And it is going to be a live transfer. And that'll go to SolidWorks, NX, Creo, AutoCAD, Inventor, Solid Edge. And again, in CATIA native format, but without a tree for these two, without a history tree for these two. Because what this is going to do, I'm going to tell it to start with the first feature. It's actually going to roll back the history tree in DesignX, and you can see what it's doing over here in SolidWorks. It's rebuilding, and look at the tree being populated. So it will actually rebuild everything in SolidWorks with that history tree. So this makes it possible then in SolidWorks or whatever the native CAD system that we support to let you roll back and make changes to it. So very powerful. Okay, so it takes a few minutes, and once it's done, you can see we've got the history tree here, and we've got our model in here with everything. So this is very powerful to be able to do all the modeling in DesignX and yet still get a history tree in the native CAD file, CAD system. So that's DesignX. Okay, so just a summary on DesignX. If you look at the benefits of DesignX, it is certainly the most powerful reverse engineering software out on the market. It has extensive point cloud tools, alignment systems, all the solid modeling tools you need, all the surfacing, including some pretty advanced surfacing, and able to work with very large data sets. When you get into some of these long-range scanners, you can get into gigs and gigs of data. And then it has the live transfer to many popular CAD systems so that you can retain that history tree if you need it. Now, some of the things to consider with DesignX is there's going to be a learning curve. Even if you know SolidWorks or another solid modeling system that's fairly similar, there's still a lot of stuff you'll have to learn. So there'll be a steeper learning curve. It is the most expensive product of all three of these, and it's still going to require a CAD system because, again, it doesn't have drawing tools, assembly tools, all the other things you might use in CAD. If you were just doing reverse engineering and going straight to CNC machining or something, or some other application where you don't need drawings and assemblies, then you'd be fine. But most people are still going to require a CAD system. So now let's take a look at all the products and just see how they compare. And this sheet, there's a lot on here. This is something we can provide to people if they'd like to see it or study it more. But if you look at the one, there's a kind of a description of what it is. But as far as alignment tools, they're all pretty good. But again, DesignX is going to have far more tools for alignments. Mesh editing tools are decent in VX Model and Geomagic for SolidWorks. Again, DesignX is going to have even more. Same with the sketching tools. Geomagic for SolidWorks, of course, really uses the sketching tools of SolidWorks. VX Model really doesn't have traditional sketching tools, as in 2D sketching tools. Yes, we can cut sections, but they're polylines. Surface modeling and editing tools, VX Model has some decent ones. And of course, Geomagic has the Mesh Fit Auto Surface from the Geomagic for SolidWorks module. But then, of course, it has all of the SolidWorks surfacing tools available. And DesignX has not only that, but some other very powerful surfacing tools. Solid modeling in VX Model is only primitives. For Geomagic for SolidWorks, it's all the tools. And for DesignX, again, it's very extensive. VX Model will handle large data sets because it does work inside the Creaform scanners environment, and those files can get large. Geomagic is going to struggle once we get over certain polygon size. As far as number of triangles, that will vary with your hardware and your setup, but that could be a consideration. And Geomagic can work with DesignX can work with huge files. VX Model doesn't really work with point clouds. Geomagic for SolidWorks has minimal tools. DesignX has all of them. Output types you can see here. Of course, with Geomagic for SolidWorks, it's all of them. In DesignX, you have the live transfer. VX Model kind of does that back and forth, as we've shown. And of course, Geomagic for SolidWorks is in SolidWorks, so whatever tool's there. So what are the applications? VX Model is great for basic CAD modeling, mesh, some organic surfaces. Geomagic for SolidWorks has this strong modeling of SolidWorks, but you got to be careful with part size. And of course, DesignX is really going to do everything those two products can do and more. So it just really depends on what you need. They all have benefits and they all have things you need to consider. And if you'd like to learn more or get a copy of this chart and have a conversation with us, happy to do that. We try to recommend the right product to customers, really based on their needs, based on what their applications are, what their budget is. There's no right or wrong answer here. Some people start with one of them and end up upgrading or switching to another one. So again, you got to look at what you're trying to do, what your skill set is, what your hardware, what kind of computers you have, and see what the right tool. So this wraps up this video. If you'd like to learn more, feel free to reach out to us. Happy to have a conversation about this and determine what the right tool might be for you for reverse engineering.